Now we start to move away from using limits to find derivatives. There are some quicker rules that we can learn. These will allow us to solve more interesting problems with derivatives more quickly. And we're going to start by looking at some basic derivative properties. So we'll look at derivatives of constant multiples, sums, and differences. And I just want to remind you, you know this already because you've been doing so much with it probably, that a derivative is just a limit. So derivatives are limits. So limit properties apply to derivatives. And so we're going to make this short and sweet just to get the point across. So some properties of limits are, if I want to take the derivative, let's use the variable x, so the derivative with respect to x, of some constant times a function of x, well, because a derivative is a limit, we can use the limit property to push the limit in and just apply it to the function and factor out the constant. So what we can do is we can factor the constant out and multiply it by the derivative of just the function. Okay? So just like we can do with limits, we can push the derivative into the function. And we'll look at the other two as well, and we'll call this video done. The next one says, if we want to look at sums, if I want to take the derivative of a sum of two functions, f of x plus g of x, then I can look at the derivative of each function and then add together. So in other words, I can look at the sum of the two independent derivatives. So this is nice. If you've got two differentiable functions, you can differentiate them independently if they're separated by a sum. And then, in fact, we don't even need to write another rule. I could have the derivative of a difference. So f of x plus or minus g of x. I can take the derivative of that sum or difference, and then it turns into a sum or difference of derivatives. And so derivatives work nicely with constant multiples, sums, and differences. Okay, so that's really important, just like they do with limits. Now, one thing I want to point out is that this is not true. Okay, so do not make this mistake, and it's a hard one to overcome initially because you think it's natural. If I take the derivative of a product of functions, unfortunately, it's not as easy as it does not equal the product of the two independent derivatives. Okay, so don't make that mistake. Get used to the fact that derivatives work nicely with constant multiples, sums, and differences. You can split derivatives in those cases. You cannot split derivatives with a product or a quotient, right? So soon we'll see a video, I'll put up a video about the product rule to talk about how to do the derivative of a product, and the quotient rule to talk about how to do the derivative of a quotient.